Hello everyone, welcome to this new video. This is the second part of the series problem of the day. So here this playlist is only mainly for people who enjoy solving math. It's not for any exam oriented, nor it's not for any coaching purpose. It's just like enjoying solving math and seeing different types of math applications that we can use in different types of problems. So that's the only main motto of this playlist. So every alternative day I'll be posting a video of this playlist problem of the day. So here comes the second video of this playlist. So come to the problem, just check the problem. Let's check the problem. Yeah, if p of x is a polynomial of least degree that has a maximum equal to 6 at x is equal to 1 and a minimum equals to 2 at x is equal to 3, then integration 0 to 1 p of x dx is equal to. That's the question. So my advice to everyone who loves solving math is just break down these questions into statements and analyze every word that has been given to you. Like understand what the question wants to tell to you, like what the question wants to ask you. Basically you need to understand every statement. So the thing is, there's an interrelation between one and the other. Here given that p of x is a polynomial, so integrating polynomial is as easy as you know that, because it's very easy. Like integrating every degree of x is very easy. It's not a big task basically. So this is very easy, but finding the polynomial is the thing that we need to solve here. So let's check that out first. And it has been given that that polynomial must be of least degree. So here comes the logical thinking part, like the essence of mathematics comes here. Like what it wants to ask you is all you need to find that in this statement itself, that p of x is a polynomial of least degree. Yes, so the polynomial can be a quadratic, cubic, biquadratic, anything, but you need to find the least degree. Okay, and that has a maximum at equals to 2 at x is equal to 1 and a minimum equals to 2 at x is equal to 3. So the extremum points have been given to us. The maximum point has been given to us, and the value is also given to us, and the minimum value given to us, and it where like the occurrence of the minimum, the point at which this minimum occurs is also given to us. So it's as easy as possible. So let's get into the solution. So basically we have that p of x is a polynomial, isn't it? P of x is a polynomial, and p dash of x has roots at 1 and 3, isn't it? We have p dash of x roots as 1 and 3 because that's the point where p of x changes the curve, concavity, isn't it? Like it has the maximum at 1 and minimum at 3, p of x. So of course p of x will have the roots as x is equal to 1 and 3, because let us assume that this is the curve of p of x. Okay, so this is the curve. Let me so let us assume this to be a p of x, and now this is a point. This is a point where we have the maximum at x is equal to 1 and minimum at x is equal to 3, isn't it? So we have a horizontal tangent here and we have a horizontal tangent here. This point we have a horizontal tangent here. So that definitely means that p dash of x is 0 at x is equal to 1 and x is equal to 3, isn't it guys? So I hope you understood this concept. So definitely p dash of x has roots as x is equal to 1 and 3, one of its roots. It can even all have other roots, we have no idea about that, but p dash of x has minimum of 2 roots, and basically that is 1 and 3. Now we need to find that p of x should be least possible, isn't it? P of x should be least possible, and integrating p dash of x dx gives you p of x, isn't it? Now, so that we need, as per the question, we need p of x to be the least possible. So I also need to search for p dash of x, which is minimum, isn't it? P dash of x can be quadratic, so that we get p of x to be a cubic. P dash of x can be bicubic, so that we get p of x to be biquadratic. So we need to search for p of x as minimum. So we need to have p dash of x as also minimum, because integrating that only we are getting p of x. So I also need to search for p dash of x which is minimum possible. Now we know that p dash of x has roots 1, 3. It can even or also the other roots, but we have no idea. So what if I assume that p dash of x has only roots 1, 3? Okay, it has only roots 1, 3. Then it is known as quadratic, isn't it? P dash of x has real roots and those are only 1, 3. Then I can assume that to be a quadratic, isn't it? I can even tell that p dash of x can be a cubic, biquadratic, or something else, and it has only 2 real roots. I can even tell that, but I need to have the least possible p dash of x, isn't it? So I'll be taking the quadratic only, because here p dash of x has the minimum of minimum roots, and that can be 1, 3. And then it can be a quadratic, which is a minimum possible case. So I can take that p dash of x as a quadratic, and I can write it as a to x minus 1 into x minus 3, because it is a quadratic. A is the coefficient of x square, so I can write the p dash of x in this form. Now come to the next place. So p dash of x, we got a conclusion that p dash of x is nothing but a into x minus 1 into x minus 3, isn't it? Now integrating p dash of x dx from x is equal to 1 to x is equal to some x. So why am I integrating from x is equal to 1? Because we know the value of polynomial at x is equal to 1, that is 6. So that's the reason I'm integrating it. So it's basically integrating a into x minus 1 into x minus 3 dx. That is from x, you can just leave it like this. You can just integrate this. Okay, so we get p of x minus p of 1 is equal to, I'll just take the a outside of the integration. It becomes x square minus 4x plus 3 dx. Okay guys, this is the integration. Now p of x is nothing but a of, integrating this, we get x cube by 3 minus 2x square plus 3x plus p of 1, which is equal to 6. Now we have been given with the value that this is what we have got p of x. Now we have given the other value that p of 3 is equal to 2, isn't it? P of 3 is equal to 2. Just substitute that, okay guys? Just substitute that. So p of 3 is equal to 2. So 2 is equal to, just substitute 3 in that equation that we have got. So a into 3 cube by 3 minus 2 into 9 plus 3 into 3 minus 4 minus it's basically like I forgot to write the limits here. I just forgot to write the limits. So it's basically 0 to it's 1 to x, 1 to x. So 1 to x, if I keep 1, I get minus 4 by 3, isn't it? So minus 4 by 3 plus 6. So we can just keep that here. So it's minus 4 by 3 plus 6. Okay, so solving that, we get a value to be 2. Okay guys, sorry, we get a value to be 3. So solving this, we get a value to be 3. So we got the value of a, so we can just get the equation. We can just put the value of a in that equation, and we can get the p of x to be x cube minus 6x square plus 9x plus 2. Okay guys, so we have come to the conclusion of p of x, that is p of x is this. Basically what we have done is, so we got the value of p dash of x, so we integrated with limits x is equal to 1 to x is equal to x, and just the same limits in the right hand side itself. So p of x minus p of 1 is equal to a, I've taken in outside because it's a constant. I can take that outside of integration, 1 to x, x square minus 4x plus 3. Now substitute 1 after integrating the value, we get 4 by 3. Because it's in a lower limit, I subtracted it, and minus p of 1 is there in the left side, just send that to the right side, you get plus 6. So we have got this value basically. Now we have the other value that we known as p of 3 is equal to 2, isn't it? So just put the value of 3 in x and equate that to 2, and when we equate that, we get the value of a, that is a is equal to 3. So substituting that a is equal to 3, we get the value of p of x. Now it's as simple as that. He just asked the value of 0 to 1 p of x dx, isn't it? So just integrate that. 0 to 1 x cube minus 6x square plus 9x plus 2 dx. So it's basically nothing but x power 4 by 4 minus 6x cube by 3, so it's 2x square, 2x cube plus 9x square by 2 plus 2x, and that you are integrating from 0 to 1. So you just put the value of 1 here, you get 1 by 4 minus 2 plus 9 by 2 plus 2. So you get this to be 9 by 2 plus 1 by 4. So it's basically 2 2s, so it's become, it is actually 19 by 4. Yeah, it's actually 19 by 4. So this is the answer. So it's a very very good problem. So we have learned lot of things here. First thing that we have learned is how to the maxima and the minima concept. Basically it's a part of maxima and minima concept. And second thing that we have learned is how to know whether how can we judge or how can we decide the least degree equation possible. Okay, least degree equation possible, least degree equation. So this is how you need to decide how to take the least degree, how to consider the least degree, and then it's all easy. We are we are almost way to the problem till we have found the p of x value, and then integrating it is not a big task. So I hope you all enjoyed this video session. This is a very very good problem, a standard hard level problem. I hope you all enjoyed this. So signing off, we'll meet you in the next video.